Overnight, while the lead human architect slept, a crew of artificial persons sat down with a design document and began to argue about it. Every log, every defect, and every decision we are about to look at is entirely real. There was nobody in the room. No human writing a prompt mid-run to nudge the system toward an answer. We simply read the minutes in the morning. They were building WeatherWyze, a software add-on that looks at a location and tells a dispatcher whether it is safe to send a repair crew into a severe storm. A blank screen is survivable for this tool. A big, honest, "we could not check this" is survivable. The only failure it cannot survive is a cheerful, confident green light over a thunderstorm, because that is how somebody gets hurt. The constraints for the night shift were absolute. The agents had zero human supervision. Their only guide was a written design blueprint, a specification document detailing the rules the system should follow. When agents follow a blueprint to the letter, they end up building the mistakes just as precisely as the features. If the initial plan contains a hidden structural flaw, high-speed execution becomes a liability. The first agent's task was to map service regions. According to the written blueprint, geographic coordinates always beat a mislabeled country field. Look at this map of the Great Lakes region. The human design claimed that coordinates always win using a standard bounding box. But Windsor, Ontario, sits south of Detroit, Michigan. There is no line of latitude that separates Canada from the United States in this area. The written instruction was physically impossible. Faced with this geographic paradox, a human engineer might widen a tolerance or delete the failing test just to get a green build. The agent actively refused to do either. It did not try to force the routing so these two awkward cities happened to pass. Instead, it halted the work. It amended the human's design document to reflect geographic reality and then rewrote the tests against that corrected design. In its task report, it closed with a concise, mechanical summary. Brief correction was appropriate and necessary. Granting an agent the jurisdiction to say the task is wrong catches a class of defect that testing cannot reach. You cannot test your way out of a bad design if the tests are being written from the same wrong description. Next comes a second agent, acting as the reviewer. It operates entirely blind to the first agent's intent. It sees only the raw code, and it cannot ask the author what they meant to do. This animated scale visualizes a mathematical oversight the reviewer spotted. The code was comparing absolute values across different units. Specifically, it weighed a 5-mile-per-hour wind gust breach directly against a 40-degree temperature breach. Because the integer 40 is numerically larger than 5, the system kept the temperature breach and silently dropped the severe wind warning. Put a repair crew on a roof in a winter storm, and the alert mentions the cold, but says nothing about the 35-mile-per-hour winds. The reviewer caught this precisely because it lacked a human's contextual bias. It read the documentation as a promise and the code as a claim. It noticed they disagreed, and it did not have a mental model of what I meant to paper over the gap. The final review phase moves past spatial boundaries and math to focus strictly on semantic structure, the actual English sentences generated for the human dispatcher. The agent intercepted a logical contradiction in the messaging. The system produced an alert claiming that a temperature of -20 degrees exceeds a 20-degree limit. -20 does not exceed 20. It falls 40 degrees below it. When the English is the product, this isn't just a typo. A sentence that argues with itself teaches the dispatcher that the system's reasoning is unreliable, undermining the authority of every other alert the product produces. By the end of the shift, the agents had successfully verified 169 internal tests. They policed spatial logic, checked unit math, and English semantics without a single human intervention. The morning after, the human architect wakes up to find a system that is reporting green across the board. They take one action. They bypass the internal test suite and directly query the live, real-world weather API. That single query uncovers a failure. A service address in Montreal silently resolves to La Prairie, a town 10 kilometers away. The API search area contained 70 nearby cities, but the system asked for a hard limit of 50. The actual nearest city fell cleanly off the list. Yet 34 internal tests passed perfectly because everyone was checking the same truncated mark data. The autonomous agents did exactly what they were designed to do. Their testing and logic corrections were mathematically and procedurally consistent. But test files and specification docs are only internal representations. The agents proved that those representations agreed with each other. They were all in total agreement, and they were all wrong together. An autonomous loop is highly capable of verifying internal coherence. It can align every piece of code you give it, but it is constitutionally incapable of verifying external contact. No matter how precise the workforce becomes, coherence is not contact. Something in every cycle must step outside the loop and touch the real world.